Okay, so we're done with question 1 to 6, essentially talking about formal geometry in the matter of angles and triangles. So we'll proceed to question 7 on this revision exercise that will focus on polygons, essentially polygons that are 4 sides and above. And if we look at question 7, the questions are quite straightforward, but will just require us to do a bit of reminder on how previous exercises are or ideas are handled. In question 7, it says find the size of each interior angle of a regular. The concept of regular means that all the sides and angles are equal. A polygon is said to be regular if all the sides and the angles are what? Equal. So A says a regular hexagon. And we are told to find the size of each exterior angle of a regular polygon. It means that all the exterior angles will also be what? Equal. Now, the sum of the exterior angles of any polygon is 360. So sum of exterior angles of any, I use the word any in an emphatic manner, is what? 360. So if the polygon is a hexagon, it means that n is equal to 6, meaning that it has 6 sides. So the exterior angle will simply be what? 360 divided by n, which will be 360 divided by what? 6, and that will be what? 60 degrees. That's for the hexagon. Now for B, it says octagon. An octagon is a polygon with what? 8 sides. So for this, we know that n will be equal to 8. So we can say that the exterior angle will be what? 360 divided by n, which will mean what? 360 divided by 8, and each side will be what? 45 degrees. Each exterior angle, or each exterior angle of an octagon will be what? 45 degrees. We go to C. In C, we are told that a decagon. Now, decagon will suggest that the number of sides will be what? 10. So the exterior angle will simply be what? 360 divided by n, which will mean 360 divided by what? 10, and that will be 36 degrees. Please take note that this only holds true when it's a regular polygon. That's why all the sides are equal. If it were not a regular polygon, the exterior angles or the interior angles will have different values, but hence we are told clearly that it's a regular polygon. This assumption would hold true. So that's how we handle question number 7. So we could just take up question 8 very quickly there, and it says that the sum of the angles of a regular polygon is what? 1800. So sum of interior, that's interior angles plural, is equal to what? 1800 degrees. Now, how many sides has this polygon? Now, interestingly enough, we have been told that it's a regular polygon. Now, there's a formula for solving this if you choose to use the formula approach. Now, the number of sides minus 2 multiplied by 180. The number of sides minus 2 multiplied by 180 will give us what? 1800. Now, this 180 suggests the sum of the angles of a triangle. N minus 2 suggests how many triangles this polygon is expected to have. So for an octagon, which is 8 sides, we would expect the number of triangles present to be what? 8 minus 2, which will give you what? 6. But let's come back a little. For a triangle, how many sides are we expecting? See, 3-sided. How many triangles are we expecting? A triangle has 3 sides. So 3 minus 1 will give me 1, which is correct, which is a triangle. For a quadrilateral, which is a 4-sided figure, it will be what? 4 minus 2, which will give me what? 2. 2 times 180 will give me 360 degrees, and that gives me an idea of what the sum of the interior angles will be. So for this one, applying these relevant concepts, I will have that n minus 2 will give me 10. So n will now be equal to 10 plus 2, and that will give me what? 12 sides. So this polygon will have 12 sides, which is called duodecagon, I think. Duodecagon for a 12-sided polygon. So that's how we handle question 7, and that's how we have handled question 8. Let's look at question number 9. In question number 9, we are told that a regular polygon has an exterior angle of what? 40 degrees. A regular polygon has an exterior angle, is regular. So first we need to take note of his regular polygon. I always teach my students to note the details. When you read questions, note the key details there. It's a regular polygon. You know that each exterior angle is what? 40 degrees. It says, what is the size of an interior angle of the polygon? There's a way out for us. There's a relationship that says that the interior angle for any polygon comma, the interior angle plus the exterior angle is equal to 180 degrees. For any polygon, particularly if it's regular. For any polygon at all, but hence we are looking at regular polygons, so it brings it to perspective for us. The interior and the exterior angle is equal to 180 degrees. Now let me give us an illustration of why that is. I'll take a pentagon, a quadrilateral for that matter. Now look at this, look at what I'm going to draw. Now take note of this, please watch. A, B, C, D are interior angles. A, B, C, D, A, B, C, D are interior angles. Now, A, B, C, D are interior angles. Now, please, let's watch. This is now, let me use W, X, Y, Z. They are what? Exterior angles. So, W, X, Y, Z are what? Exterior angles. W, X, Y, Z are what? Exterior angles. Now, if that is understood, we draw from the previous argument that angles on a straight line is what? 180. So for every point of this figure, let me now call this P, Q, R, S. For every point on this polygon, the interior and the exterior angles are related by this concept of adjacent angles on a straight line. So that idea, if it's well grasped, you understand what I'm doing here. So if the interior angle is 40, so it means that from here the interior angle plus 40 will be equal to 180, meaning that one interior angle of this figure will be 180 minus what? 40, and that will give you 140 degrees. So the interior angle in this setup is what? 140 degrees. Okay? Now the next question says, that's for question A. Now B says, what is the sum of the interior angles of the polygon? What is the sum of the interior angles? So what is the sum of the interior angles of the polygon? Now there are different ways you can solve this problem. First of all, I don't know the number of sides of this polygon. I don't know the number of sides. So I will say, recall that what? Exterior angle is equal to 360 over n. What is n? N is the number of sides, is that not? So I can make n the subject of the formula. So n will be equal to 360 divided by, what is the exterior angles in this setup? Is what? 40 degrees, is that not? Fine. So this will be 40 degrees. And that will give me 360 divided by 40. And that will give me 9, is that not? So n is equal to what? 9. So we have 9 what? Sides. Fine. So what will now be the sum of the interior angles? So sum of interior angles, note I have now changed to plural, will now be equal to what? Number of sides 9 minus 2 times 180. So that will simply be what? 7 times 180. What is 7 times 180? That should give you something like 126. Am I right with that? I'll give 126, 1260 degrees. And that is the sum of the interior angles of the polygon. So that takes care of question number 9. Happens here. Now, from method 1, we know from 9a, we know that the interior angle is equal to 140 degrees. We also know that the number of sides will be equal to what? 360 over what? 9, because of our concept of number of sides 360 over what? 40, because of our concept of what? Exterior angles. So this will give me 9. Now, remember that for the angle, the interior angle to be 140 and it being a regular polygon, it means all the sides must have what? 140 degrees. So the sum of interior angles of polygon will simply be what? 140 times 9. And 140 times 9 will give me this same answer. So if you don't use this method, you can use this method. You still get the same answer. Whether you're using this method or this method, you will get the same answer. And that's something very wonderful about maths. No matter the method you use, as long as the logical approach is right, you must get the same answer. Alright, so that takes care of that. So let's go to question 10. In question 10 of our, still using our essential mathematics, you discover that the question says, find the number of sides of a regular polygon whose interior angle is twice the exterior angle. Now you see geometry meeting with algebra. Question 10. It happens to be a jam-pass question. Find the number of sides of a polygon, a regular one, whose interior angle is 2 times that of the exterior angle. So let the exterior angle be x. So if the exterior angle is x, it will mean that therefore interior angle will be equal to what? 2x. Now what does that mean? It means 2x plus x will be equal to 180 degrees. What's the reason for that? Angles on a what? Straight line. Angles on a straight line will sum up to 180 degrees. We have said, now this is the property they are testing, that at a point on the polygon, the interior angle plus the exterior angle must give you what? 180 degrees. So with that, you have that what? 3x will be equal to 180 and x will simply be what? 60 degrees. So if x is equal to 60 degrees, you are told to find the number of sides. Now this x equal to 60 degrees, it means that that's the interior angle. So number of sides, which is equal to n, will simply be what? The interior 360 divided by the exterior angle. So that will be 360 divided by 60. Obviously this figure will be 6. So this polygon has what? 6 sides. So that takes care of question number 10. This figure will have what? 6 sides. A heptagon. Heptagon has what? Heptagon has what? Heptagon will have what? 7 sides. So heptagon has 7 sides, and the angles are given as what? 103, 120 degrees, 130 degrees, and what? 118 degrees. And we are told that the remaining angles are equal. The remaining angles are equal. So we'll say that let each remaining angle be x. So for a heptagon, we expect 7 sides. 4 sides have been given to us. So 4 from 7 will give me what? 3. So which means that there are 3 sides that are missing. So what do? We now need to look for the sum of the angles of what? A heptagon. So sum of angles of heptagon, sum of interior angles of heptagon will simply be what? N. How many sides? 7 minus 2 multiplied by what? 180 degrees. So that will be 5 times 180, and if you do that right, that will be 900 degrees. So having gotten 900 degrees, the next thing you need to do is to solve to obtain what those remaining 3 angles will be. So let's look at this. So this will now be what? 103 plus 120 plus 130 plus 118 plus 3 of these angles, 3x remaining, will be equal to what? 900 degrees. So we will add all of this together. This will give me, just do that, 223 plus 248. So do that together, that should give me 471. If I've done that correctly, that should give me 471. So 900 minus 471 will give me 429. I've done that correctly. So it means that 3x is equal to 429, and that will give me that x is equal to 143. So if I've done my arithmetic correctly, I should have that the answer should be 143. I always allow my students to do the confirmation on this. I'm not so bothered about the arithmetic. I'm more concerned about the concept idea being tested here, being that of what? Sum of angles and then the behavior of interior angles of polygons. So do the arithmetic and confirm that what I have done is right. In question 12, we are told that a pentagon is such that one of its exterior angle is what? 60 degrees. The 2 others are 90 minus n each, while the remaining angles are 30 plus 2m. Now I talked about what? The exterior angle. So let's start by building. The discussion is about what? Exterior angles. Now we are told that one of them is what? 60 degrees. Then he said 2 others are what? 90 minus m. So I'll just indicate that there are 2 of them. Then I'm told that the remaining one are what? 30 plus that's 30 plus what? 30 plus 2m. Remaining mean what? 2 also, because for a pentagon we expect to have what? 5 sides. So if this is given and this is 2 of this is given, it means that this one will simply be what? This one will simply be what? 2 sides accounted for. Now we know that the sum of exterior angles of any polygon is what? 360 degrees. Sum of the exterior angles of any polygon at all is 360 degrees. So what does that tell us? It means that 60 plus 90 minus m, two of them, plus two of these also will be equal to 360 degrees. Right, so that takes care of that. Now the next thing I want to do, there are two options for me. I can use my approach. I'm saying that all these things are even, so I divide through by 2. I always do that to ensure that I reduce the figures I'm going to work with. So this will be 30 plus 90 minus m plus 30 plus 2m equal to 180 degrees. So if that is done correctly, just my technique, student might choose to do otherwise. I don't always like to expand. Once I spot even numbers, it means that I can divide through. So I'll add this becomes 120, 150. So this will be what? 150 minus m plus 2m will give me what? Plus m equal to 180. So m will simply be what? 180 minus 150. That will be what? 30 degrees. So the answer is what? 30 degrees. So m simply will be what? 30 degrees. And that close out on that will help us close out on the matter of this aspect, talking about what? Sum of angles of a polygon, exterior angles, and the like. So the next aspect we will go into is that tends more towards what is called trigonometry. Trig of angles, cast rule, and the likes. So we'll close out on this. Remember that these are essentially revision work from your SS1. So to be able to do well in your SS2 work, we expect that actually in your geometry you should have done all these topics. So just a test for you to see how well you remember these topics, and then if you still have some issues with them, then you may need to take more exercises on them. And I think with this you should be able to flow along.